Robert J. Scherer, professor of physics at Vanderbilt University who conducted the study in question, attempted to determine the minimum size of a primordial black hole that could cause serious harm to a human or even result in death. Examining this scenario can help scientists narrow and refine the search for dark matter. It is believed that about 27% of the entire universe consists of dark matter, though its exact nature is still not fully understood. In today's universe, black holes usually form when the fuel of very massive stars runs out and they collapse under their own gravitational pressure. Therefore, to form a stellar black hole, a large amount of mass must be concentrated in a very small point. For example, stars about 20 times the mass of the Sun can create stellar black holes. Obviously, such black holes cannot pass through the human body, since humans are insignificant compared to 20 times the mass of the Sun. In other words, our bodies are far too small to obstruct this type of black hole. Of course, if someone were to fall into a black hole for any reason, the result would be catastrophic. The person's body would be stretched like spaghetti under the black hole's immense gravitational force and destroyed. On the other hand, primordial black holes are hypothetical types thought to have formed in the first few seconds after the universe came into existence, when all the matter that later formed stars and galaxies was extremely compressed and dense. NASA explains, in those early moments, portions of hot matter may have been dense enough for black holes to form. The mass of these black holes could range from 100,000 times lighter than a paperclip to 100,000 times heavier than the Sun. Then, as the universe rapidly expanded and cooled, the conditions for black hole formation in this way ended. If such black holes did form, they may still exist in the universe today. Some researchers have even suggested that primordial black holes as small as an atom could pass through Earth every day without causing the slightest harm, and perhaps larger ones might pass through once every 1,000 years. To date, none of these primordial black holes have been directly detected, but recently a group of researchers reported the possible discovery of gravitational waves associated with a primordial black hole named S251,112 cm. Interestingly, in this study and possibly in dark matter investigations, these black holes could have a wide variety of sizes. The new paper was inspired by earlier research on macroscopic dark matter, or macros. This type of dark matter could range in size from very small particles to objects as large as asteroids. Scherer explained in his paper that study shows that collisions of macro dark matter with the human body could be destructive enough that the absence of evidence for such collisions allows us to set useful limits on the mass and cross-section of this type of dark matter. Simply put, if dark matter were large and heavy and collided with the human body, we would certainly see its effects. Since no such evidence exists, scientists can infer that dark matter is neither very large nor very heavy. According to Scherer's reasoning, doing the same for primordial black holes could set similar limits for them. Primordial black holes are considered another possible candidate for real dark matter. Scherer stated, "I knew I could apply some of those calculations to the study of primordial black holes as well." Recent observations of gravitational waves from black hole mergers and new images of black holes have revived interest in the subject. Moreover, I recall reading a science fiction story in the 1970s in which a person dies after a black hole passes through their body. I wanted to see if such a thing could actually happen. Scherer's paper examines two different effects that might harm the human body. First, a primordial black hole could create a supersonic shock wave along its path, destroying tissues in its way. Second, tidal gravitational forces could tear apart cells and cause serious damage. Scherer calculated the minimum energy required to cause damage similar to a bullet passing through the human body and estimated that the black hole's mass would need to be about 1.4 × 1017 grams, roughly equivalent to the mass of an asteroid. The damage caused by tidal forces is even more interesting. First, what do we mean by tidal forces? As NASA explains, tidal force is the difference in gravitational strength between 2 points. The Moon's gravitational field creates a tidal force across Earth's diameter, deforming the planet. This force also produces meter-scale tides in solid Earth and larger tides in liquid oceans. Whenever tidal force exceeds the cohesion and integrity of a body, that body will be torn apart. Tidal forces generated by a small black hole would have fascinating effects on the human body. Scherer explains, when a primordial black hole passes through the human body, it creates strong tidal forces around itself. These forces stretch nearby cells, and if strong enough, the cells will rupture. The cells most sensitive to this destruction are likely human brain cells. Scherer concludes, primordial black holes are theoretically possible, but they may not exist at all in the universe. If a primordial black hole the size of an asteroid or larger were to pass through your body, it could cause severe injury or even death, with an effect similar to a bullet wound. In contrast, a smaller primordial black hole could pass through your body without you even noticing and cause no harm. However, the density and abundance of these black holes in the universe are so low that such an encounter is practically almost never going to happen.